Okay, we're back. This is just the second half. So I left off on this slide. So I'd gone through in general what the electromagnetic spectrum is, difference between radioactivity and radiation, where they intersect and where they're different, and that causes confusion. Right? Not all radiation, as you'll see, is dangerous. And then we talked about some characteristics of waves, frequency, wavelength. What I want you to know is what frequency is, what wavelength is, and how they relate to energy. Basically, high frequency, high energy. Low wavelength will be high frequency and therefore high energy. So shorter waves are higher energy, longer waves are lower energy, and so on. All right, and then what ionizing radiation is, meaning ionizing can break chemical bonds. Ionizing can also remove electrons from things. All right, so let's just kind of work our way through. So cosmic rays are also gamma rays, and they're a form of radiation emitted by radioactive elements and also from the sun. Most of this doesn't get to the Earth's atmosphere, as we know, right, in The Incredible Hulk. It's gamma rays that turn him into the Incredible Hulk. Most of these don't get to us because they're blocked by the Earth's atmosphere. But if you were to travel in space, you'd have to have protection from that type of stuff. And it's high energy. It's ionizing. All right, X-rays. Also, the sun does give off X-rays when we can create X-rays here. X-rays are ionizing radiation. Some elements will give off radiation as well. We'll talk about that later. So things like gamma rays, though most of them comes from the sun, we do get some from sources on the planet. X-rays were discovered in 1895. This is also a form of ionizing radiation by a gentleman named Röntgen, and he was studying lead in the glow of a cathode tube, and he saw bones. Okay, and y'all know X-rays can penetrate tissue but not bone, and they'll expose film. An X-ray or a radiograph is actually more like a shadow. Right? Imagine you're looking at the shadow. Right? But it's ionizing radiation. All right, and then we move into ultraviolet. And that is also ionizing radiation. Ultraviolet is important for vitamin D, to make vitamin D. So to have vitamin D, your body needs a couple things, and one of it is actually sunlight. It can be used to disinfect, so if you irradiate something with ultraviolet radiation, that's one means to kill bacteria. Causes tanning, sunburn, can also cause mutations. And we'll spend a little bit more time on ultraviolet as towards the end of these slides. Right? The visible spectrum, okay, so once you get into the visible region, it's non-ionizing. And remember, these are wavelengths, so the ultraviolet is down here, so the violet side is the high energy. You can tell if something absorbs in the visible region, because anything that has color means it absorbs light in the visible region. And it's interesting that the color you see is actually not the color absorbed, it's the opposite. This is the color wheel. So for example, green plants absorb red light. Okay, if you get UV protecting glasses, everything looks a little bit yellow because it absorbs the purple, some of the violet as well. Right. One of the labs, we're not doing labs this summer, but one of the labs deals with this a little bit. All right, so you all know if you look at just regular light and you run it through a prism, it'll break the light up into its components and you can actually see this. And other than an album cover, where else have you seen this in nature? That's right, rainbows. Okay, that's because you have droplets that are small enough that they'll cause the light to break. Interestingly, if you take light from the sun, you get this spectrum here that's called a continuous spectrum. Right? The word continuous means everything. It's a smear. That's a continuous spectrum. If you take an element and you burn it and then look at the light through a prism, you get what are called bright line spectra or discrete spectra. So for example, helium has only these lines. Mercury has only these lines. Neon has only these. And every element has a unique spectrum. It's like a fingerprint. So if you've ever wondered, how do astronomers know that this star that's 50 light years away from us, so far away it takes light 50 years to get here, how do they know what it's made of? Because no one went and got a spoonful and analyzed it. They can tell from the spectra of what's coming out, of the light coming out. All right. Also, interestingly, the fact that these are discrete, these are actually caused in an element by electrons moving between the layers or shells, and this was the evidence that electrons exist in discrete layers, was atomic spectra. And we're not going to go into all that detail, but that's, if you wonder how do we know that electrons exist in discrete layers, it's based on this. each of these lines is electrons moving between those layers, like jumping, like going up the steps of a ladder. All right, the other end is infrared, and this is also non-ionizing, so they've just to the low energy end of the visible spectrum. And we typically see this as heat. This is how night vision goggles work. And what this does is it causes bonds to stretch, and when the bonds relax, some of the energy is given off as heat. And we'll talk about this more when we look at the unit on climate change. But just if you want to prove that to you, see how it works. If you jump up and down for a couple minutes, the energy that pushed you up, right? All that energy is released when you come back down. But if you keep doing it, some of the energy comes off as heat. You get warm, right? So that's kind of the idea. Pit vipers, like rattlesnakes, the little pits on their faces sense infrared as well. So anything that's alive gives off heat, and it's going to give off some infrared. Microwaves are also non-ionizing radiation. When microwave ovens first came out, when I was a teenager, a lot of people were really worried about it because they thought it's going to kill you. It's, you know, you're going to get cancer by standing too close to it, that kind of thing. So what microwaves do is they cause water molecules in the food to spin around, and of course those water molecules rub up against other things, and that causes heat, and that's actually what cooks the food. There you go. Radio waves are also non-ionizing. Radio waves are used in radio, obviously. So if you listen to radio, you're picking up radio frequencies. Cell phones use radio frequencies as well, which is non-ionizing. So do cell phones cause cancer? Ready? No. The answer is no. There's been a lot of studies. There has been no data to support it. All the data was no different than just random variation. So nothing has come out that says that at this time. Who knows what's going to happen in 1,000 years or 50 years, but they've been around for a while now. I'd say they're dangerous because you're not paying attention to your surroundings, but other than that, no. Right. So a summary of the effect of electromagnetic radiation on bonds, right? So the ones that kind of we'll go from the low end. Okay, infrared doesn't, radio frequency doesn't do anything. Microwaves can cause molecules to rotate. Infrared, right, can cause bonds to bend, to stretch and bend. And we'll talk about that with greenhouse. Ultraviolet, now you get into ionizing. So bonds can be broken. You can knock electrons off of single atoms as well. Interestingly, each type of bond absorbs energy differently. Right? And of course, X-rays and gamma rays are very ionizing, but we don't have to worry about them so much because we're not really bombarded with them. A little bit more about ultraviolet because you're bombarded with that. Right, so ultraviolet's actually broken up into 3 subregions. The longer wave, which are the lower energy, right? This comes down to the planet, passes through the ozone layer. The shortest wave, which is the highest energy, never really gets here. So we don't really worry about UVC. You do get some UVB. Mostly 98% of it is UVA, so just a little bit less than 2% is UVB. So if you buy a sunscreen and it advertises that it will protect you from UVC, you're wasting your money, right? Because it's not getting here anyway. So let's just look at the 3 types of ultraviolet. So ultraviolet, UVA, most of the ultraviolet, that's black light, right? Can damage collagen fibers a little bit, and also vitamin A. Activates melanin pigment already present in upper skin cells, creates a tan, can cause skin to lose plasticity, can enhance the development of skin cancers. If you want to look more about it, click on this link. I just checked it, it's good. This will take you to a paper from the World Health Organization. This is a blacklight poster. I thought it was cool. Interestingly, too, a lot of, to prevent counterfeiting of money, will have, and your driver's license will even have some images that you can only see under ultraviolet. UVB, okay, more energy, less than 2%. It can stimulate cells to protect themselves by thickening, which is why people who are out in the sun for years and years and years get kind of that thick, leathery skin. Can cause sunburn, right? They don't really know how it can cause cancer, but typically, anytime cells divide, they can screw up, and so it's kind of there is a statistical aspect to cancer. So burning, getting yourself burned, your skin has to heal, right? But it's also a lot of energy. So I don't know how old these numbers are, but this is what skin cancer, people die from it. Okay? And it's relatively preventable because you can wear sunscreen, right? And it's stronger closer to the equator, higher altitude because right, the Earth's atmosphere isn't as thick. During the summer, the sun's closer to us. Middle of the day, snow, sand, pavement, water reflects light back up. So, watch yourself, use some sunscreen, that kind of thing, minimize exposures. Right. So just a quick summary, the last slide for electromagnetic radiation. This radiation in this class is mostly from the sun, travels at light speed, ranges in energy and danger. Ionizing radiation, which starts at UV, can break and form chemical bonds, can remove electrons, and that can be dangerous, right? Infrared can stretch bonds, microwaves can rotate, and some energy doesn't do anything, right? And there are important environmental considerations and also for energy source, and we'll talk about that in slides coming soon. That's it for these slides. You can start looking at some of the homework material as well.